Hello everyone, welcome to this vlog. My name is Satya. So this is the 7th installation of simple home network setup. So I'll be discussing today about a new concept. Before dwelling into the topic, I would like to congratulate Royal Challengers Bengaluru team for winning the IPL 2025. Right? Many congratulations. Very proud of you guys, so very well done. Okay, so let's now dwell into the topic itself. Today I'll be discussing about what is the difference between wired LAN hosts and wireless LAN hosts. So as you see here in the diagram that I always discuss about, so we have LAN Ethernet and Wi-Fi. So these are the two things that is predominantly used to connect to the internet using our LAN host 1 or LAN host 2 LAN clients. So what exactly is the difference between these wired hosts, which are called as LAN or Ethernet hosts, or wireless hosts, which are called as Wi-Fi or wireless LAN hosts? Okay, let's dwell into the topic. So as indicated here, I am trying to tell the differences between wired hosts and wireless hosts. The first difference is wired hosts support CSMA CD. Okay, so what does CSMA CD mean? And it is under 802.3 umbrella, technology umbrella. Okay, so what exactly is 802.3? 802.3 is an IEEE standard which supports Ethernet protocol. Ethernet is wired LAN host. When we connect our computer to the Ethernet cable, wired cable, it is called as Ethernet, right? So, and what does the CSMA CD mean? CSMA stands for carrier sense multiple access collision detection. Whenever you connect your LAN host 1 or LAN host 2 or any host for that matter to the residential router through Ethernet cable, then you will get higher speeds. How it is higher speed is, there is a protocol mechanism within the wired host which will determine whether there will be a collision detection or not, right? So I should say collision detection or not, it should be like collision detection is there, right? So before sending a frame, we are very sure we detect that there are no other things transmitting. So there is a protocol overhead which determines that there is no collision that will occur. So we are trying to use the wired medium that is called as coaxial cable, right? Coaxial Ethernet cable, which is called as LAN cable. So there you send a frame and that frame will not collide with any other frames because you don't know LAN host 1 and LAN host 2 are there. Here LAN host 1 and LAN host 2 both can send at the same time and the packets may collide and there might be no transmission properly done, right? To avoid that, we use this CSMA CD technology in Ethernet frames, Ethernet technology, right, in 802.3 protocol. So we avoid the collision, we detect the collisions, and then once the collision is detected, we will not send the frame, and only when the medium is clear after the protocol overhead, we send the frame, right? So that is the main difference between 802.3 and 802.11, which is wireless Wi-Fi hosts, right? So let's see what exactly is wireless hosts. Support CSMA CA and it is under 802.11 umbrella. So I told what are the benefits of having Ethernet technology. And now let me tell you what are the benefits of having wireless technology. So wireless technology, I did a typo here, so let me correct it, CSMA CA. So first thing is wireless hosts, which are Wi-Fi hosts, are coming under 802.11 umbrella. This is a technology 802.11 as a different protocols, right, under which wireless hosts also come into the picture. Wireless hosts. CSMA CA stands for Carrier Sense Multiple Access. That means multiple people can access. Collision avoidance. We avoid the collision. There we detect, in Ethernet technology, we detect the collision and not send it. Here we avoid the collisions. How we do avoid the collision is, here also there is a protocol overhead. We will differ from sending, right, the frame, wireless frame onto the wireless network for short interframe seconds, SIFs, which is usually 5 microseconds, right? So microsecond, second itself is very small. Microsecond is 10 to the power of -6 of the second, right? That is, it will wait really short time, 5 microseconds before, or maybe any thing, but it is very less time that it sees that the medium is free, then only it sends. There are predefined parameters, SIFs, diffs and all. So after SIFs interval, it will send the frame, but it will, once it has sent the frame successfully, it will wait for DIFS seconds. It's called as differentiated interframe seconds. So it will wait for that many seconds before doing SIFs, that is short interframe seconds. So the total time that we will wait is diffs, DIFS plus SIFs in wireless host when they are sending the frame. That means to say totally you may wait for, like for example, 30 microseconds, right? 30 microseconds we will wait, then we will send the frame. If frame collides with another frame during that time, then your packet will be lost. So that is a disadvantage of wireless hosts. They try to avoid the collision, but there might be frames which might collide, which might be using the medium at the same time, but chances are very less because Wi-Fi is also medium is also very strong. That's why whenever we are using the Wi-Fi channel, for example, I will tell you what is Wi-Fi channel later in the discussion, in the training. But in the Wi-Fi channel, if too many hosts are there, then you will see some delay in buffering. For example, you're watching a movie, then there might be freeze of the frame, right? So you may see some delay in the movie being played, or a sport, or some cricket game you are watching. There will be delay in streaming the content actually. So because we avoid the collision here, we wait for certain time, diffs plus sifs, and then send it. If the other other host also is sending at the same time, it may collide and your packet might be retransmitted. That's why your throughput rate will come down. Throughput in the sense how much rate at which you can transfer. Rate usually in computers is mentioned as bits per second, right? So that is the main difference. So Ethernet hosts or CSMA CD, usually very reliable network. They detect the collision, and then only the collision is detected. They will not send the frame. If the collision is not there, then only they will send the frame. Here it is collision avoidance. We wait for a certain time and then send the frame. If at the same time other host sends, then they will collide and the frame might be lost. The frame has to be retransmitted. So your throughput rate will come down in wireless hosts. Okay. Due to this, right, what is the next difference is wired hosts can transmit at 400 Gbps, whereas wireless Wi-Fi hosts can transmit at 40 Gbps theoretically. Okay, now what I mean by 400 Gbps, Gbps is gigabits per second. That means, as I told in the just a moments before, that bits per second is a metric used to determine the rate at which computers can transfer, or the devices can transfer the data or transmit the data, right? So if you wired hosts are much more faster, that is 400 Gbps, they can send 400 gigabits per second, whereas Wi-Fi host theoretically can transmit at 40 Gbps, that is gigabits per second. 40 gigabits per second can be transmitted per second theoretically, right? There is a spelling mistake here. Theoretically. Okay, so that is another major advantage of Ethernet. So you can tell me that till now whatever I am telling, Ethernet is having higher score than wireless hosts. Then what is the use of using wireless host? Flexibility, right? So as your wired connection, you have to be very close. There is a wired medium, right? Coaxial cable is connected, Ethernet cable, LAN cable is connected to your router, so you have to be very close to the router and start working. Whereas in Wi-Fi or wireless medium, you can be anywhere in the home and you can access the internet. So that is the advantage of wireless LAN host, that is reliability. Sorry, wireless LAN host, what is the advantage is flexibility of connecting to internet anywhere in the home, right? Whereas Ethernet, you have to be very close to the box, residential box, which is this box, black box, which I am highlighting here, right? And how, like in Ethernet, there have been lot of multiplexing and demultiplexing technologies that have already been developed, and terabits per second are also being sent at the Ethernet technology, right? But Wi-Fi is still evolving. As I told you, we wait for SIFs plus diffs seconds to transmit a packet. This is a pure wireless LAN technology without any overhead. Ethernet has very less overhead. There is source MAC address, destination MAC address, and the frame check sequence. That's all. That's the header. When you send a packet, as I told you in my previous simple home network videos, I have told you how the packet is constructed. Source MAC address, destination MAC address, source IP address, destination IP address, transport layer, that is UDP or TCP transport, source port, destination port, and the actual payload which you are sending, right? In Ethernet, only source, destination, frame check sequence is there. In wireless, there are lot of other parameters, right? So usually the overhead is too much in wireless. So when you send the medium, whatever theoretical 40 Gbps, it may get reduced because of the overhead only, protocol overhead. And plus you are waiting for a certain time to send the frame because it is collision avoidance. So wireless medium is not reliable and throughput rate is very less in wireless, in Wi-Fi mediums. Then there are a lot of technologies that have been coming up, like how we multiplex and demultiplex the technology, how we encode the frames, right? There are a lot of technologies that are being discovered or invented in Wi-Fi medium, 802.11 protocol. Latest is Wi-Fi 7, right? But most widely used is 802.11 AC, right? But commercially Wi-Fi 6 is also predominantly used. Wi-Fi 7 is still coming, right? So then I want to describe in Wi-Fi channel mechanism, right? Your residential router will send beacons. That's a protocol message called as beacon, BACAON. Beacon means sending somebody a alert message saying I am here. So your wireless router will send beacon message to all the Wi-Fi hosts in the LAN saying that I am here, my SSID is this one. So SSID is usually the name of the wireless router. If more than one wireless router is present in the area. Usually in metropolitan cities like Bengaluru, there will be lot of people living in the apartments. So one apartment will be close to other apartment. Maybe one wireless router is on the one side of the wall, other wireless router is on the other side of the wall. So that's not a good way of installing the wireless router. But if by mistake they've installed it, then you will have a channel interference, right? So you are operating at, there are 2.4 gigahertz as 11 channels, out of which most interference free channels are channel 1, 6 and channel 11. If everybody starts using channel 6, then there will be co-channel interference. If you're using channel 7 or 8, then there will be neighbor channel interference, right? So there will be a lot of interference which will lead to the rate, whatever rate I told you here, 40 Gbps will keep on falling down. So in wireless, first of all, protocol overhead is there, right? The frame is too big compared to Ethernet frame. Then we wait for certain time before using the medium. Because of that, rate will come down. Then because of the channel being shared by other hosts, more over the host, the lesser the bandwidth we will get, and the rate will again come down, right? So friends, if you want to know more about wired 802.3 protocol set and wireless 802.11 protocol set, please subscribe to this channel and comment saying that we want to know more about these technologies. I'll be very happy to help and share more videos about these protocols. Okay, thank you. Thumbs up.